What? Yes? Why don't you mooch off of your friend? There you go. There you go. That's better.
He says no.
Okay, check them.
What page is this on? I don't think I got Joe's back.
New packets in the back.
Alright.
They're up there.
Shucks. I got one. I got him.
In the back of the bin.
Okay, I'm lost.
You were in the right place.
You said up
Didn't you
there.
say to, instead of writing 3 to write cubic?
If it's one variable. The only one of everything up there that is a single variable is number 21, which is why I wrote linear. Remember, the degrees, if it's one variable, they get special names. If there's more than one variable, then they don't get the special name, you just identify what the degree is. Okay?
And that is on a.
This was section 4.1. So whatever the assignment portion of that is.
Oh no.
Well, neither do I.
Wasn't here.
Page 132.
Okay.
Then, number 26 and 27. Notice that both of those had single variable. So those will get the special names. What is something degree 2 called?
Quadratic.
There you go.
Cubic.
And cubic. Remember that if they had one variable, then they get special names. We had a little bit of vocabulary. We always have those. The difference on 28-29, degree of polynomial versus degree of monomial, was sometimes you had to find the degree of a specific term instead of an entire expression. And in that case, you had to add them all up, all those exponents. Down below, they just say an example. So what they have doesn't matter. In fact, if you have exactly what they have, right here, when I go and look at yours, then I know you didn't do this. You think you're smart by just copying the board. Don't cheat, dumb. Okay? Can you make a trinomial of the 12th degree? What is a trinomial? 3 terms. So it's got to have 3 things. This plus this plus this. Or minus. And it says it's a 12th degree. So all that has to be true is the biggest exponent or collection of exponents is 12. I could have just said x to the 12th plus x minus 1. That would work. It's got 3 terms, biggest degree is 12. I could have said 19 pi x y 3 9 plus 8 z to the 12th minus 24 over e x to the 7th, y to the 5th. It's 3 terms, and every single one of them adds up to an exponent of 12. So the biggest exponent is 12. Okay, so there's a bunch of different answers you could have given them. What else we got? A binomial of the first degree. The only way you make a binomial of the first degree is to have some variable to the first, so no other exponent on there, and then some constant. That's the only way you make that one. So you could have said x plus 8. 329y minus 11. Okay, that would have worked. Because I would only have 2 terms. If I have 537.1x minus 12,544. That's a binomial. It's got 2 terms. That's the first degree because it only has an x to the 1. It's just got big numbers with it. Remember, we're looking at the number of terms and we're looking at the variables. They're exponents. And a monomial with 3 variables and a degree of 4. The only way you do that is to have something variable, 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 and one of them has a 2 on it. Okay? So those are just examples and ways that I can make them. If you need to check to see if yours worked, does yours work? Does yours meet the condition? Then that's something you should be asking. So, we walk through everything. Here we go. Y'all got your books, right? Okay. I still see a few over there, but we got kids missing. Do we have 4.1 polynomials? I would like for you to write both of them. Classify by number of terms and its degree. If it gets a special name, please make sure you state it. No, Gavin, you don't have to do it.
I was gonna ask if I can comment on my post.
Oh, that's right, you missed that too. Yep. Mr. Spear has taken the ACT review today. I thought I was going to have to because of Mr. Jameson being gone, but nope. You should be good to come down. Might have my geeks in here, but we'll tell them to be quiet.
I have to go to like 3 other classrooms, so.
You know that I'm not a stickler on the deadlines, though, so go take care of them first. You done? Okay. We'll find out. And it should be fairly quick. Is anyone still going? Okay. I see 3 terms, so I have a trinomial. I see 2 terms, so I have a binomial. For degree, this one, big dog is 2, so it is a degree 2, which gets it a special name that this, because it has one variable, is a quadratic. This, on the other hand, I'd have to take a little invisible one here. This term has a degree of 9. This term has a degree of 6. The larger of the two is 9, so it is a degree 9.
What? The y has a human form.
We went through that. That was one of the very first things we did in this class, when we very first talked about exponents in September. If there's nothing there, then there's a little invisible one, and we did that specifically in class on Wednesday. Nice and simple. You got it, you got it, you got it, you got it. You remembered that it has the special name. Good thing that we just went through 1 or 2 of those from our homework and jogged your memory. Okay? Any questions about it? All right. I said we started off pretty easy because we need to know what we're even talking about. We need to know how to read the directions of the problems. Now we're actually going to do the problems. I hope that you're okay with today because it's not too different than what you've done before. It's just combining like terms, but they're bigger and uglier. Okay? To be a like term, it has to follow some rules. Those rules are, well, they say the same variables and the same exponents. I want to add to that. The rules for being like terms, maybe you put this down in that bottom right corner where we usually have some blank space. To be a like term, it has to fit 3 rules. Rule number 1, they have to have the same variables. Rule number 2, they have to have the same exponents. And rule number 3 that they do not say in this sentence here is you have to have the same exponent in the same variable. The same exponent on the same variable. So here's what I mean. Right here, notice that they both have a C and a D. They both have a 2 and an invisible 1. They both have a C, they both have a D, they both have a 2, they both have a 1. Why aren't they like terms? Because the exponents were in different spots. And you can tell that they're not the same term or the same kind of term if you write them out longhand. What does C squared mean? 2 of them. Remember writing these out longhand? This is 7C times D. This is 9C times D. Those are two very different things. CCD versus CDD are not the same critter. Okay, that's like my 4-year-old calling every alligator a dinosaur. Okay? Yeah, it's a big honking reptile. It's got scales, it's got claws, it's got teeth. Like, nah, buddy, that's not a dinosaur. Okay? They are very similar. They are related. Some of them went underwater and didn't really evolve for the last how many million years. Other ones, they just gained more feathers and started flapping around instead of running. Y'all know that birds are descended directly from dinosaurs, right?
Yeah, I learned
And there is increasing evidence that all dinosaurs actually did have feathers.
I learned that from Jurassic Park.
Legit. Dinosaurs had feathers. Like, have you ever watched The Good Dinosaur, the Pixar movie?
We didn't have it.
Okay. The little raptor things that stole all of their buffalo, that's more like it. Literally. So, now, can't prove it because the feathers would have been something that immediately sloughed off and there's not enough fossil evidence to prove it. But that's been a long-standing theory, and they are discovering more and more evidence as our archaeological techniques get better. But the idea is, these are different critters. I can't say 7 pandas plus 9 grizzlies make 16 panda grizzlies. Okay, it doesn't work that way. You have known this all throughout the school year by every time we were solving an equation and I said something like 3x plus 2 minus 5x equals 18. Very first thing, Paxton, get the line! Okay, the very first thing that we always did was say, chop up your terms. Which terms go together? We were finding like terms. I can't put the 2 with the 5 or the 3 because they're not like terms. So we would combine 3x's minus 5x's is negative 2x's. And when we played the Who's Lonely game, we would subtract 2. The reason we didn't bring the x over is because they're not like terms. X does not go with 18. Remember, it's like mating a turtle with a giraffe. Fun to watch, doesn't accomplish anything. So what we're doing today is that, except instead of something really obvious like turtle and a giraffe, now it's going to be more like a mountain lion with a lynx, where they're both going to look awful similar.
Yeah, that's my old middle school.
Okay? We were the polar bears. Northeast North Dakota. And it was cold. Okay? You were pirates?
Yeah.
Did the school song say something about we are the pirates? It would have been fun. So, I want you to look up here and see how much uglier this time they are. Okay?
We still have to do it.
Well, yeah.
Like,
So, they're going to show you kind of a longer way to do this. We're going to get better at it. Where if I have 3x's plus 12x's, we know that's just 15x's, right? But what you never really showed was that if I have 3x's and 12x's, I can use reverse distribution. It's called factoring, and that is bringing us into chapter 4. It's called factoring, where instead of distributing into a thing, I take things out. Okay, it's just the reverse, where I take that x out, and isn't that how I kind of did it in my head? I said 3 plus 12. 3x plus 12x, it's 15x. You didn't say 3x's and 12x's. You just said 3 plus 12 is 15. And it has an x with it. You were doing this, but in your head. Okay? Look over here. They both got a y squared. So if I take that y squared out, it says I've got this much y squared. So you've been doing that for literal years now. You just probably haven't seen it written out like that for a good long while. Yeah, that's what the whole front page is. It's about putting like terms together. So, head over to example 1. Come on, Frank, let's go. Find the sum of these two. What does sum mean? What about total?
addition.
Add, there you go. Okay. So that's how they write them, is they say I'm going to take this thing plus this thing. Do you see anything right here that I might have to distribute? Okay. And 1 doesn't change anything, right? Because 1 times a thing is itself. So I'm just bringing that up because it might be cropping up here soon. Since I don't have to do anything with that, see if I can get the right color here.
So if it was a negative instead of a plus, then would we do the 1?
Then I would put my invisible 1 there and I would distribute my negative. We are heading there because the section is called add and subtract like terms. So since I don't have to worry about distributing anything, those parentheses don't really matter. If those parentheses don't really matter, then adding a negative also doesn't really matter. I get to just look for like terms. Every time there's a plus or a minus, I chop it up, and I look in those boxes and I say, ahem, are there any other W cubeds?
Yes.
Where?
-3W.
So those two go together. 2W cubes minus 3W cubes. Do you two need to be separated? What I've always done with these, don't murder your paper, but just kind of like light shade or just a quick cross them out, something, so you know don't use this again. I've already done it. Then I go again and ask, do I have any other W squareds? Yup, this guy. The W cubed got to party with the W cubed. The W squared gets to party with the other W squared.
And then 11 is all alone.
And 11 is lonely. 11's just going to kind of hang out next to them. You all know how this works. You're teenagers, right? These two, you got this group of friends, and then these two start dating, and then those two start dating, and you're left standing there like,
Okay.
all right. Okay? It gets awkward, right? Well, that's what's going on here is at the end of this, I just have to take this 11 and just kind of,
Set it there.
you're just there. You're just there all awkward like. And then combine your like terms. So can you tell me, incorrect, what is 2 waffles minus 3 waffles? Negative 1 waffle. So I don't know, you owe me a waffle. So negative, okay, I'm just going to write the whole thing, but we'll talk about it later. Negative 1w cubed. Okay, I got that part out of the way. 4 waffles plus waffle. What number is in front of w squared?
So it's going to be 5 waffles.
5 waffles. In this case, 5w squared. And 11,
Well,
11 is just everybody hurts sometimes. He's just hanging out there. This is not the right answer. It's close. It's very, very, very close. When I tell you that this isn't simplified.
Oh, we add the exponents together.
No?
What?
Well, that's a w cubed and a w squared and a no w at all. Those aren't like critters.
The ones on top, so like 2w, 3w.
We did that.
6.
No. Oh, this and this?
Yeah.
No, 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 no. These are different. This is like saying the big honkin' popcorn bucket at the movies. This is the little bag at the movies. This is that dinky little tray that you give the kid.
With the gummies.
Yeah. Those, they're not the same thing together, right? I can't put big bucket with decent bag with what the crap. Those aren't the same thing, so I can't add them together. It's just done. What I'm saying is it's not simplified because I don't need to write the 1. Remember? Most of the time that 1 is invisible. So I'm going to erase the 1, and I'm just going to have my negative in front of it. Okay? Now, hold on. I heard my robot talking to me here. Okay. Now, be aware that if I switched over to that one, then my audio, me talking, is going to be a little bit less on the video. You saying something you ain't supposed to is going to be louder on the video, so shut your mouth. Oh. Okay? It also has a higher chance of picking up that little squeal. So, go to example 2. Okay, just like Landon said, what if I'm subtracting? Now, I'm going to run through this the way the book runs through this, and I really am not a fan of it. But I just want to show you how they do it. First, I'm going to box in this term. And then I'm going to look everywhere else and say, do I have any other x to the 4th, y to the 5th? Yes. Yeah. Right here. Mm-hmm. And see how in between there it says subtract that stuff? Mm-hmm. That's why it's 2x to the 4th, y to the 5th, minus, how many of them are there?
2.
What number is in front of this?
1.
The invisible 1. Okay? So x to the 4th, y to the 5th. Then I go for the next term. Every time I run into a plus or minus. Do I have any other x, y to the 5th? Yep.
and 2xy to the fifth. See how this is a positive 3, but I'm subtracting it. That's why this says minus 3xy to the fifth. I'm subtracting everything that's in those parentheses. And then, poor guy,
Big John. He's throwing the party by himself.
see how it is still subtract that thing though,
Oh, he's not
because it's
showing.
all in parentheses. So it's minus 2x to the fourth, and there is no other, just plain x to the fourth, so that's it. We said there's a little invisible one here. You might have to be writing that little invisible one in your work to get through this. If I say, 2 chupacabras minus 1 chupacabra,
What is a chupacabra? It's, hairless, dog. It's a mog, that's what's actually.
It's a log.
A mog.
It's a fictional creature, well, it's a mythological creature that may or may not be real, just like Bigfoot, that kills people.
I've seen
Isn't
it.
it like a
You look
snake?
around it.
No.
It's just
This is
a
my first video.
big ugly piece thing, that's all we need to worry about. How about over here? If I have 2 tacos minus 3 tacos,
You have -1 taco.
negative 1 tacos, you owe me a taco.
I was like, wait, did you pull one out of your stomach?
And then, at the end, minus 2x to the fourth, well, as you say, is just Joe. Big Joe. Okay? But do you get what they did? They said this side minus that side, this side minus that side, this side minus that side.
It's very hard to understand, but I somewhat get it.
Now here's what I would prefer to do instead of that. Right up here, you got just a little bit of room. The way that I have always taught this, and most kids would prefer, is, you said there's a little invisible one here, right?
Yeah.
And you remember distributing, so what I'm gonna do is distribute to all of these, minus x to the fourth, y to the fifth. Distribute here, minus 3xy to the fifth. Distribute here, minus 2x to the fourth. And then I'll just drop these down. And you say, why did you do that? Well, now, if I break it up like that, now I don't have to deal with parentheses. Now I don't have to remember to minus the thing. Now I just get to say which of those go together. Well, x to the fourth, y to the fifth, x to the fourth, y to the fifth. X, y to the fifth, x, y to the fifth.
It's a lot easier, and then that was chilling.
And, as you say, go. Isn't it easier to just distribute the negative instead of remembering to subtract every time?
You should just call the last guy Zoinkies.
Call him his monkeys?
Yeah.
No thanks.
Keep talking about Zoinkies. What are you saying though?
So. Try it. Five.
Was that you?
Okay. Try them. Instead of breaking them up in boxes. But, yeah, you got it in one great spot. What is 2 caramel apples plus caramel apples? 3 caramel apples. You owe me $4. You paid me $9. Good. Now they're running us through very slow. They're making us write out everything. They're making us put in all these blanks. We don't have to do it this low and slow after the fact. But right now, we're going to use that so we just make sure everything's going right. Okay? Make sure everyone's doing it right, make sure everyone's on the same page, and then we'll take away all the blanks and parentheses. Right. Yes, yes, no, no, no. Bravo. Micah, what is 2 apples plus 1 apple?
4.
5.
3 apples. 17. 2 apples plus an apple. What if I said like 2 circles plus 1 circle? 3 circles. So 2 is and then over here, you can check that on the calculator. If I say 1x plus 9x. There you go. Good job checking.
What number is supposed to go to?
Well, just these 2 for now.
Ah, easy. I'm confused at number 2.
Okay.
So like right here, it says negative 5x is 2, or negative 5x squared plus.
Not negative 5x squared plus, and then they have a parenthesis. They have that because there are no other x squareds. So now they start with x.
Okay.
Do you have any other just x's? So x plus 9x.
Oh, okay. And then this one, maybe, maybe 6 plus maybe 5.
Yes. There you go. Stack them together. Okay. You say, here's an a squared, here's an a squared. 2 apples plus apple is 3 apples, but they're not apples, they're a squareds. You owe me $4, you pay me $9. Looks like I'm up positive $5. Okay? On the next one, you notice how it started with negative 5x squared and nothing in parentheses with it? Well, that's because he was all alone. Okay, so that one's just there. And then I look for an x because they're saying, hey, go find more x's. So I add in another 9x.
I'm surprised I put them in the right order.
I have a negative 6, I have a negative 5. So negative 6 plus a negative 5. Put together whatever goes together. You owe me $6, and then you add another $5 debt. Borrowed money from
11,
me
negative
twice
11.
for lunch. Okay? You
Must
owe
be
me 11,
really
that's why it's
smart.
minus 11.
It must be really smart.
X's plus 9x's. Gavin.
Oh. I put them in the wrong order, but,
What's x plus 9x?
5. Wait.
What's
Which one
x
are we
plus
on?
9x? Number 2, what is x plus 9x?
Oh. I put them in a different order, so it's 10x.
10x's. Yes.
another name.
Okay? And then, just hanging out by himself, negative 5x squared.
Yeah, definitely get some of that.
Alright. Flip it over. If that was adding things, you know what's coming next.
Subtracting.
No.
Going further.
Just give us more.
Yeah,
Oh
boy.
my god.
Chill out.
Sorry. He's
You
not
need to
sure.
show off the monster.
So what I would like you to do, instead of their plus minus thing, instead of subtract this, subtract this, subtract this, what I would prefer that you do, and you said that it seemed a little easier, is we're gonna start by putting our negative 1 right here, and we're gonna distribute it. So negative 8 x squared, y squared. We're gonna distribute it. Negative 5 xy. We're gonna distribute it. Uh-oh. What's a negative 1 times a negative 6y squared? Positive 6y squared. And then all this stuff is just gonna drop. Negative 7x squared y squared plus 2xy minus y squared. See, if I write it all in one big long chain like that, now I see a plus sign, chop it up. I see a minus sign, chop it up. I see a minus sign, chop it up. I see a minus sign, chop it up. I see a plus sign, chop it up. And you look at all of these boxes,
Oh.
and you say, which of them go together?
The first one and the fourth one. I'm not good at matching them.
Okay, step by step, I see negative 7 x squared y squared, any other x squared y squareds. So, over here, negative 8 x squared y squared. I ask, are there any other x, y's?
Give me a second. Yeah.
Where?
No.
So one there.
X, Y's?
and then- Yeah.
Oh, I saw you.
No, that's where the 5 is.
No, there.
Ha.
April Fools.
So I have 2xy's minus 5xy's.
I forgot it's April Fool's. I forgot to buy fireworks.
Oh my god. What are you planning?
Y'all just need to be quiet because you're a little too giggly, a little too fast. Okay? Rein it in a little bit. Finally, do I have any just y squareds? Y squareds. So those two go together. I have a negative y squared and a 6y squared. Remember, it's the variables and the exponents that have to be the same. The number in front of it just tells you how many of them you have. Okay. What is negative 7 things minus 8 things?
I have no clue.
Negative 15 things. Don't change the exponents. Big honking letters, neon highlighter around it. When combining like terms, you do not change the exponents. Negative 7 waffles minus 8 waffles is negative 15 waffles, but they're not waffles, they're x squared y squareds. 2 things minus 5 things is negative 3 things. Write the xy. What number is in front of this y squared?
1.
So what is negative 1 plus 6?
Negative 7.
No.
7.
plus 6, negative 1 plus 6. You owe me $1, you find $6 laying around.
5.
You're up 5. Okay. What we're going to start doing, though, pretty quick here is we're not going to write this step 2. We're going to go directly from this line to answer. Because we should be able to do basic arithmetic in our head. Or on our calculator if we need to check. Okay. I see 4 problems. They are all subtract. What's the first thing you should do on every one of these?
Add them together, separate.
Wow, I just heard 3 things and none of them were right.
Distribute the negative 1 to every.
Distribute the negative 1. Okay? The first thing that you should be doing with all of these is putting your little invisible negative 1 there and distributing it to the back half. These 4, give them a try. Do 2 problems, right? Yeah.
One more. They don't get multiple around. I get the first two, but not the last.
That's too long.
So can I sit on the chair?
You cannot. I don't know what to do that. No, it's a negative. I got it now. Was negative 5 minus 7. Okay. So if I say negative 5 minus 7, it's negative 12. Negative times negative, so that's positive. Negative times positive, right? Negative and negative, positive. Okay, so all of that is good. So I'm going to say, yeah. Now, you already called it positive. They said minus negative. Okay, mod circle, right? Mod circle. Y is the plus. Negative y is minus 2y. Regular numbers is regular numbers. 1 plus 4. what's 8x plus 4x? You owe me a y, you owe me 2 more y. That's what we're doing every time. Now, if this starts getting uglier, for instance, okay, you gotta write it over here, you got room.
You know how to do it.
Right? Sacred symbols, singular. Okay. How we doing, boss lady? Just work with my thing. Good? Feeling good? Pretty good. All right. Sometimes when they get all those other exponents in there, it just looks grosser than it is.
Yeah, the way it's taught us is actually good.
Yeah, I don't like their parenthesis thing,
Yeah.
their grouping thing. I'm not a fan. Okay. Well, it looks like most of us are there, so I'm gonna start going through these, even though I know some of you are finishing up 6 or 7. I lied. 1, 2, 3, 4, 5, 6, 7, 8, 9.
Oh no.
Volunteer get drafted.
Four.
Geneva called it. Go, get him.
I called 5.
Paxton got 5. Volunteer get drafted.
I'll do 7.
All right.
Easy one.
Get it, my lady. Okay. Okay, you got the right things in the right spots. Now we just watch our signs as we're combining terms. And what's the exponent on it? That's right, the exponents don't change. Ta-da! Alright, 5. Paxton.
Alright.
Here we go. Remember how to work it? Poke the single page with arrows going in all 4 directions. Yep. Then next to 5. Yep, left to right first, and then attaboy, we got it. Whoa! Attaboy.
Okay.
Unfortunately, I'm wrong. Not quite. Now, you had everything in the first line correct. What do we do when we subtract a negative?
Oh.
So, right here,
So it would be 12x.
okay? 4x, negative y's minus 2y's. You were right, but I think you kind of split it.
Yeah.
You owe me a yodel. You lost a bet and you owe me 2 more yodels. You owe me 3 yodels.
Yodel. Oh, okay.
And then, I think we just kind of split it like that. Add the opposite. 5. There we go. Okay, so the way that they wrote it, I think that just kind of messed us up, is because there's too many parentheses and negatives there. Now, what if, Paxton, you said you liked the way that I did it instead.
Yeah.
What if I have 8x minus y plus 1 minus negative 4x y minus 4, parentheses. And instead, I put my 1 here and said 8x minus y plus 1 plus 4x minus 2y plus 4. How much better does that look?
A lot better.
If I just draw my boxes around it,
Yeah, you can combine them a lot easier.
right? It's more like sorting Legos.
Like negative y and 2y would go together.
Okay. And when you start seeing that, things just make a little more sense where you said this goes with this,
Yeah.
negative 3y. And then I scribble them out.
1 and 4 would go together.
And I say 1 goes with 4.
Then 8 and 4x.
And 8x with 4x is 12x.
Yeah, that's a lot healthier.
Okay? If that is your jam, do it. Okay? In fact, that's probably the way I'm going to do it for the rest of the year, but we got to get through a few more. No one called 6.
I got you.
You got it?
Okay.
Okay.
I've got it done. I don't know about that. So.
See what you got. Impress me.
I'll do that. Alright, next.
Oh, I just forgot to write the letter. That happens.
Yep.
You'll see in the second hour this morning, that was kind of a mess. Been a long, long sleep deprived week.
I sat down in the shower. I was so tired.
I've done that before. You just sit on the floor in the shower and just
You turn it up.
contemplate life.
Turn it up real hot so it's still warm. Just
Okay.
sit there.
I want you to look at what Max is doing. Does he have stuff in the right spot?
That's not Paxton.
That's
That's-
Paxton.
Is it June yet?
I wish.
It's
It's July.
Oh,
Fireworks go, fireworks.
wow.
That's the
Is it
first time
rated
I've ever,
R?
and that's the first time that you've ever done that.
It's been a long week.
The
It's
Harley notes.
been a very long week. I'm gonna say, that's weird. Okay, added
Don't you lower your head a little bit?
minus 5. I think we're very, very, very close. Very, very, very close. It's something really tiny and it messed us up. Check this out.
I put in that one though.
But then it changes what I do here. Because if I say, you owe me 1 penguin, you give me 2 penguins. I now have 1 penguin, right? So instead of being 1 plus 2 and then you just called it a negative, you actually have to have negative 1 plus 2. Okay? So it just means that coefficient disappears because it's a positive. T squared. Okay? Those signs, the negative is the bane of the math student since the dawn of math. Landon, you want the 7. Good job.
It's like the Bowser of math.
Batman.
A Batman. I know Batman.
Hey. Pay attention. It's been flying. I do believe you have the mama needs a vacation right now.
I need a vacation.
Oh, I had 2 weeks off of school.
I'm skipping tomorrow.
Alright. I think we can move this one back here to at least try to get a little distance. Maybe I can give you the meter stick.
I'll take it. It's been a lot better this time.
yourself or anything.
I'm calm right now.
How
I didn't
about
do
you?
yoga.
Shush. Alright.
How can you do it on the spot?
He shuts his flapper and he listens. Okay? See how g to the 6 is with g to the 6th. S squared g squared with f squared g squared. A long time ago, the way that I would do this with kids, I did it PlayStation symbol style. Okay? Micah called them the sacred symbols, and he ain't wrong.
Yes.
Okay?
That's what they're called.
Where all of my g to the 6th became this. All of my constants became this. And all of my f squared g squareds became this. And I would have kids rewrite the problem like this. Okay, I would have them distribute the -1 and then like this.
Oh, that's a good idea.
Doesn't that look super easy to rearrange?
It looks like something on a kindergarten would do.
Okay, now this is why people like me become math teachers. This is how the problem looks to me. Like in my head, this is how it looks. It's just colored shapes and boxes.
Yeah.
Okay?
You
I
forgot
distributed the negative.
parentheses, so that changes.
I already distributed the negative.
No.
Oh, I did.
What class is that?
Spanish.
I wanted
No,
this Spanish.
because
I'll
it's
be doing
supposed to be
my
positive
movies.
6 into the negative 6.
Yeah, I
Here,
heard
it's
that.
gotta be, but it's minus
What about it?
3 thing plus 6 thing minus 9 thing.
Oh, yeah.
I already distributed to it.
I got some more stuff.
Does this look better to you?
A lot better.
Would you be able to say, well, that's just -9 minus 3 is -15, -12 thing? Could you just say -12 thing? And then tell me that 6 minus 6 is no more thing. And tell me that 3 plus 9 is 12 thing. Now all you have to do is go back in there and call this g to the 6th. Call this constant, so I just get rid of it. And you're done. Okay?
How do you come up with things like this?
Because that's the way I see it.
Oh.
Alright. You flip it over and you see some are plus, some are minus. Some are plus, some are minus.
That's a homework.
I want to do this one together first.
Okay.
Okay.
Oh my goodness.
Do you remember what the word perimeter means?
Kind of wondered. It's where you can't.
For example,
It's the amount of space on the outside.
whenever it is time for you to work, I am walking the perimeter of the room. Where am I walking?
The boundaries.
The boundaries, the outside. Think of a guard walking the perimeter. Okay? Little stick figure Steve is going to come up here and he's going to walk the perimeter of the yard. So when they say find the perimeter, that just means find out how far he walked.
Oh, but this is like
X plus 15, 2x, x minus 3, and 2x. Stop flapping. Stop noise making. Every time I run into a plus or a minus, it's a new term. And if I ask you, it works really nice if I can highlight them up here. Are there any other x's? X
2x.
plus 2x is how much?
3x.
Plus x
4x.
plus
6x.
2x.
6x.
So altogether I have x plus 2x plus x plus 2x is 6x. Over here, do I have any other constants? 15 with negative 3, and that's why I put that line in front of the plus or minus. It tells me it's a negative 3. So when I put those two together, now I know 15 minus 3 is 12, but positive. Okay? Number 8 through stop sign. Because what I'm picking up from the room is those of us who get it are good, we got it. Those of us who probably need some more practice are the ones who are flapping our lips and maybe getting off task, and it's not going to do any good for you to do that practice individually right now with time to work, because you're not going to do it. Instead, I'll just let you get done what you need to get done if you're going to get it done. With a reminder that you now have less than 2 months to get yourself at a particular grade if you don't want to be back in this room again next year with the current freshmen. 8 through stop sign, everything. Good thing you got 4 days.